Hey everyone! Today I'm diving into something every researcher should master: study design. Whether you're a seasoned pro or just starting out, understanding study design is crucial. So let's break it down. Study design is basically the blueprint for your research. It decides how you'll collect, analyze, and interpret your data. The goal? Ensure your results are valid, reliable, and accurate. First up, we have descriptive studies. These aim to describe the characteristics of a population or phenomenon. They don't answer how or why questions, but they provide a snapshot of what's happening. Under descriptive studies, we have case reports and case series. A case report is a detailed presentation of a single patient's medical history. Imagine documenting a rare side effect from a new drug. Then there's case series, which involves multiple case reports with similar diagnoses, like a series of reports on patients with a rare form of cancer. Next, we have cross-sectional studies. These observational studies analyze data from a population at a specific point in time. Think of a survey assessing the prevalence of diabetes in a community. And finally, ecological studies. These analyze data based on groups rather than individuals, like investigating the correlation between pollution levels and asthma rates in different cities. Moving on to analytical studies. These are used to understand relationships between variables, often to identify causes or risk factors for diseases or conditions. We have case control studies, where you compare patients with a disease, cases, to those without, controls, to identify risk factors. For example, comparing smoking history between lung cancer patients and healthy individuals. Then there are cohort studies. These follow a group of people over time to see who develops the outcome of interest. Imagine following a cohort of nurses to study the long-term effects of night shifts on health. Now let's talk about experimental studies. These involve manipulating variables to determine their effects. The most common type, randomized controlled trials, or RCTs. In RCTs, participants are randomly assigned to receive either the intervention or a placebo/control. There's also quasi-experimental studies. These are similar to RCTs but without random assignment. For instance, implementing a new educational program in one school and comparing outcomes with another school not using the program. Now let's highlight some key elements of study design. First, the research question. This is the clear, focused question that guides your study. For example, does a new drug reduce blood pressure more effectively than the current standard treatment? Next, the population. This is the group your study aims to generalize its findings to, like adults age 40, 60 with hypertension. Then the sample, a subset of the population selected for the study, for instance 200 adults age 40, 60 with hypertension randomly selected from a city. Variables are next. The independent variable is what you manipulate or categorize. In our example, it's the type of drug, new versus standard. The dependent variable is the outcome measured, like blood pressure levels. Data collection methods are crucial too. For example, using blood pressure monitors to record readings at baseline and after treatment. Data analysis involves statistical methods to analyze the data and test hypotheses. You might use t-tests to compare blood pressure changes between groups. And finally, bias and confounding. It's essential to identify and minimize factors that could distort your findings. Randomization helps to control for confounding variables. Let's look at some practical examples. For a descriptive study, you might ask, what is the prevalence of obesity among high school students? And use a cross-sectional survey in a specific region. For an analytical study, your question could be, does smoking increase the risk of developing lung cancer? You'd use a case control study comparing the smoking habits of lung cancer patients and healthy controls. And for an experimental study, imagine asking, is a new medication more effective than the standard treatment for reducing blood pressure? You'd design an RCT, randomly assigning participants to either the new medication or the standard treatment. In conclusion, study design is a fundamental aspect of research that influences the reliability and validity of your findings. By carefully selecting the appropriate design and rigorously controlling for biases and confounding variables, you can provide robust evidence to answer your research questions. Thanks for watching.